what I'm going to do is walk through today our orthodontic wire bender, and it will give you an idea of what the workflow is, what the software is like, and what to expect on the whole thing. So great. Let me go ahead and get started. Okay, so first things first, to give you an overview of what we're talking about here, we make an orthodontic version of our machine here, and what it does is, of course, bend Holly retainers, C-clasps, and things of that nature. And the most important thing is to really have that software as simple as possible. So I see some more people joining. Just a second. Okay, so the first thing on the software to note is that when you boot it for the first time, it'll give you a getting started guide. And the whole vision behind that is that we want to get people up and running as quickly as possible. We've even had people, making parts within minutes. Really, the training time is supposed to be negligent, So this will walk you through exactly what you're doing, what the different toolbars are, what they do, and how they do that. And I'm going to walk you through that right now. And then how to import a part, orient it correctly, and start making your bow. So I'll skip the tour. If you ever need that tour again, it's under getting started. So let's start here. So I'm going to import an upper, and the flat plane looks good. And I'm just going to orient it so that it's symmetrical, pointing downwards. Okay, so I have my upper. Now we want to put an occlusal plane. Now this is like just 3 points, so you can, it looks like a water line. Push that to where you need it. Let me just hide these. So next, we want to put in a loop. We have two algorithms. One is for a smooth loop, essentially going across, and then the other one is for contour. It'll fit the inside or the outside really nicely. We'll do a loop, an adjustment loop on left and right. We'll put it from 3 to 3 right there. So there we are. We have our loop and our bow. We can adjust these. You can just pull them wherever you want, But let's put that around there. And pull this one around there. Great. Now, next thing we want to do is add some points to the inside. So we'll let's get rid of snap to plane, get rid of smooth, and we'll want to add some points going in like that. Now, one thing you might want is to take these points and you want to offset them from the anatomy a bit, just so that you can get the acrylic under there. So let's say we'll lift them about 1 millimeter. And what the red part does here is showing that I'm intersecting the anatomy. So we can go back to adding a point. I can add a point here, but maybe this one I don't want to snap to anything. So I can just pull and push this point right here. Like that. We might want to place it like right there. And again, the tooltips here on the right give you a constant reminder of what you're looking at. So green means it's a selected point. This sort of bluish purple is showing that it's snapped to the plane and the model, while these are just snapped to the model, these pinkish ones. All right, so with that, I'm going to add some more points over here. Maybe again, I'll add just sort of a free point, and then the other ones I want to just snap to the model. So I'll go back to this point here, make it free. And that's basically it. So I have my bow. This guy's a little crazy. Move that in. The other thing you could do is you could select these points. and leave them alone, or you can pull them off the anatomy a bit if you'd like. Oops. So you could just offset them, and I'm just pulling them away a little bit if you want. Sorry about that. So take this point, offset it out, take these points, offset them out a bit if you want, or you can want them as tight as possible. It's up to you. Then the other thing you can do is you can add a new part. For example, this one we won't snap to plane. Let's just say we're doing a C clasp. You just bring that around. Add a new part on this side. And there you go. So from there, we're going to save and export. And then this brings us to our Bender software. So our Bender software really is more about the tooling. So if I'm going to import, sorry, let's say my bow here. So one thing you can do is you can animate and just see that everything looks like it's going to come out fine. Looks like it will. No problems. And then you can just run the program. Yeah, it's basically like this. We have a very tight spacing between bends, so we can get really smooth shapes, but we can also get very nice hard shapes. And then it'll bend it out, and maybe 45 seconds, maybe a minute for a retainer arch there, or a C clasp is even faster. Does anybody have any questions? Oh, there was a question that we had an Adams class. So we do not have a feature just yet, although we are working on it right now where we can just automatically drop an Adams clasp into the machine, but into the software, but the machine can bend it as it is for sure. But what we're working on right now is we'll just add an Adams clasp feature. The machine runs on 110 horsepower, basically, 10 amps, no air compressor needed, no, it's 100% electric, and it is all servo driven, so it's very precise in terms of the motors and things like that. The other typical questions are, what's the maintenance like? The maintenance is really quite simple. I mean, all the bearings are sealed, all the internal screws are sealed. I mean, maybe once in a year or something, you might want to check the grease on one of the rails, but that's about it. Honestly, it doesn't really come up that much. The tools have a grease groove on them as well. I really don't see the grease ever coming out. The cutter life has been tested to about 100,000 cuts, and it still continues to cut. So, but I would say that we would guarantee it to 50,000, which in many of these cases is more than the life that is expected. We work with lab length wire, 14-inch wire, or you can work with a spool. We'll support either. It doesn't matter to us. We will be ultimately providing wire. If you guys want to buy our wire, you don't have to. What we'll do is, again, make sure that all the wires works very, very well with our machine. A typical question comes up is how much tooling do I need for the different wires? So let's say you're doing 032 and 030, you can get away with the same tooling. If you're doing 028 and occasionally 040, you're going to want two sets of tools there because the difference between the two of them is quite large from a relative perspective. So really, you can tell us what is your sweet spot in terms of how many tools you need and how many types of wires you'd like to use off the bat, and then we can work with you on that. Okay. Are there any other questions pertaining to what this can do? If not, I'll show you one more thing. You wouldn't do this in the same part, but let's just do it anyway. You can add a new part here. Let's drop in a plane on the inside here. The question was, can you save your own wire templates? Yes, absolutely you can. You can calibrate for whatever wire you want, and it'll compensate for the spring back of that wire. If what I'm going to do here is I'll do something on the lingual side, contoured, and you could just say I want, a bow from here to here. So I'll just shut off the visibility of the other parts, and you can see like you're all set right there. And now you can just save and export and bend. So it's quite flexible. The wire diameters we've tested are 0.16 to any size. Honestly, we can go very large, 2 millimeter, but I don't think that comes up all that often. But yeah, but for the sweet spot, we've tested a lot of 0.32, 0.30, and 0.36. So the question is, can we put a curl at the end here? We can. I think what might be a little bit challenging is put a curl on both ends, because it'll intersect with the machine. The first one will be fine, and then the second one may start to intersect with the machine. We do not have a template for putting little curls, but if that's something that's highly requested, we're happy to do that. All right. So yeah, I mean, our intent here is, again, to really make the training as minimal as possible, and really to make the CAD creation portion of this very, very fast, and then the accuracy, repeatability, and smoothness of the shapes coming out of the machine to be optimal. A lot of that has to do with the tooling that we've designed, and we're really proud of what we've made, and we'd love for you guys to test it or give us any feedback. Does the model need to be closed? No, but it is better. But no, it doesn't have to be closed, honestly. But what I've seen occasionally is we get like well, I don't know if it's a bad scan or it's basically, if it's closed, I know what the inside is and what the outside is. When it's not closed, occasionally we've noticed that it's reversed, where like the inside would be shaded and the outside would be black, and it's just hard to display. And basically, if you get into the surfacing of it, the surface normals are reversed. So it just has to be a clean scan. But we can work, for us, it doesn't really matter, because that first import, you will orient the part correctly. So the other questions are typically, what is the minimum distance in between bends? Ours is about 1.6 for 0.8 wire. You can push it even tighter if you want, but it's about, I'm sorry, I said 0.8 wire, that's in millimeters, but it's about twice the wire diameter or a little less. Really, we go about 50% higher than wire diameter. And it says, if we design and bend the labial bow and the clasp for the holly retainer, can we also design the acrylic base and print it afterwards? That's something we're looking at very seriously right now, is the ability to design the acrylic. Again, if that's something that's highly demanded, that we certainly would do that, and we can export these files to subtract it from the acrylic, then print the two of them and put them together. A question about what's the difference between DT, LT, and 3D. So DT is the CAD creation software. Let's call it the art software, where you make the wire that you want. 3D and LT, 3D is a fully featured software here. You can adjust material profiles, you can make hand programs, you can design your own part, you can control a machine. And then the LT version is this, but it's defeatured so that it's basically just the printer. Okay. I'll just stop sharing for a second. Yeah, so if you guys have any additional questions, or feel free to even turn on your mic and let me know. But I hope I've answered all your questions, or type them in the chat, and we can go from there. How often do you have to change out the tooling? I would say if you're sticking within the wire range, like let's say you're doing 028 and 030, most of the time you would never really need to change it. It will be very, very durable for this gauge wire. So you wouldn't really need to change it. When you do change it, it's really just 4 screws, and you pull them out, and then all the parts that come back together are all self-aligning, so you don't have to go through like a calibration or an aligning step or anything like that. You just 4 screws, pull it out, put the new one in, tighten the 4 screws back down. The calibration on the machine is sometimes for the wire, so we will pre-calibrate it for general 304 stainless steel, and then you might get batches that are harder or softer or whatever. In that case, really it's just a handful of data points on each side. You just say, like, let's say it's overbending or underbending, and you get a consistent result like that. You can measure a few angles, and then it will compensate for that spring back constantly, and that you shouldn't need to do that within that wire batch. If it's very, very close, but it's just slightly underbending, we have a feature where you can just say, like, I'll bend it a little bit more, and then you don't have to recalibrate, because it's essentially the same material. It's just maybe slightly stiffer than anticipated. And what's really happening there is that what we found from the wire suppliers is that the stiffness of the material can vary, plus or minus 20%, which is pretty broad. And so if for example you get a batch or a wire that's just a little stiffer, you can just nudge it in the software. You don't have to recalibrate the software. So I'm not familiar with Dentorum wires, but we can calibrate any wire you want. So if you want to use cobalt chrome, you want to use something else, yeah, it doesn't matter. You can calibrate or use whatever wire you like. Are you able to bend round and rectangular arch wires? Yes. I have to say we haven't tested a ton of rectangular arch wire, but I don't see any reason why we can't. I could say in other industries we bend rectangular wire, and it's fine. We just change the collet to have a rectangular hole, which is straightforward, and we would be able to accommodate that. Yeah, the software does warn you if it's going to intersect the machine. And honestly, it's not the biggest, like, nothing's going to break, but it might show that the wire might get bent if it's going to intersect the machine, and it'll give you that warning. You're asking what kind of scanner? Really, we've just up to this date, we've been mostly just getting scans from labs, so we're kind of agnostic to what kind of scanner. And really, the scans will be saved as an STL file, and we can import that file. And I think the other question is, can you do this in iOS? No, the software is Windows-based, Windows 11. Oh, I'm sorry. I read iOS as the Apple software. We do build to order, and we also have some in stock. And if you'd want something very custom on the tooling, that is also possible. So it's both. They're all made in Brooklyn, New York. And we ship from here. The dimensions of the machine can be found on our website and our brochures. I'll pull that up. So the machine. So there's full specs. Well, it's not working for me. So you can download these, and it'll show you the machine's about 40 inches by 18 inches wide by 27 inches tall. So 40 inches left to right. It's about 240 pounds, and it really just needs 110. If you have 220, we'll take 220. That's fine. 50 or 60 hertz. So regular US power. Oh, I'm sorry. I wasn't sharing that, but you can find that on our site. Or we'll be happy to send you a brochure. Do we have local resellers in Europe? We're working on that, but we can also sell directly to Europe, and we have a CE certification in Europe. So we're able to ship to Europe. And so it'll take European power as well. So 50 hertz, 240, or 210, 220, doesn't matter. All right, well, thanks everybody. This is really great. I'm glad we are able to share what we've made. We really hope you enjoy it and find it useful in your workflow. Please reach out to us. If you send an email to sales@pensalabs.com, it'll go to multiple people, or reach out straight to Josh Fidel, who put his name in the chat, and we'll go from there. All right. Thanks, everyone.